KMNO4. So those examples we are not looking at. So what we are looking at here are only cyclic compounds. So C5H10, there is a possibility of cyclopentane, then butane with one substitution. Next, wherever you substitute this methyl, it will be same. And next possibility with 3-membered with ethyl substitution, 3-membered ring with 2-methyl substitution on same carbon, 3-membered ring with 2 substitution on 2 different carbons. So these are the possible isomers which do not decolorize KMNO4. And when you are treating it with Br2, as all hydrogens are equivalent, we will be getting only one product. Wherever is substitute, it is same, that is bromocyclopentane. So one product is possible. And when it comes to methyl cyclobutane, we have one possibility here, another possibility here, third possibility here, and fourth possibility here. All 4 are different hydrogens here. They are not of same type. So 1, 2, 3, 4. So 4 products will be getting. Now let us check the different hydrogens in ethyl cyclopropane. One possibility here, second possibility here, third possibility here, and fourth possibility here. This is also same, fourth only. That means once again 4 more products will be getting. And now let us go to the fourth one. Here or here same. Here already its valence is completed with 4 bonds, no hydrogens are present. And here or here it makes no difference. So it has only 2 types of hydrogen. And when it comes to 1,2-dimethyl cyclopropane, he is not asking stereoisomers, only structural. So we are not going into the details of cis or trans. One type of hydrogen here, second type will be here, and third type will be here. So it gives 3 products. So if I add them, 1 plus 4, 5 plus 4, 9 plus 2, 11 plus 3. So we are getting 14 isomers. All right. Suppose as it is memory based question, if we are not sure whether they are asked cold KMNO4 after the reaction or before only. If they ask the possible structural isomers of C5H10 which do not decolorize KMNO4 without this reaction, then what happens? You should see only structural isomers of these compounds. So 1, 2, 3, 4, 5 will be getting. Only if they ask structural. Stereo, if they ask, last compound has 2 chiral centers, similar chiral centers. So you will have 3 more isomers. Okay, so whichever is asked accordingly, you answer it. If this is the question as it is, then 14. Only about C5H10 if they ask, and structural isomers that do not decolorize cold alkaline KMNO4 is 5, and including stereo if they ask, then it will be 7. Let us move on to one more question. This is of chemical kinetics. First order reaction rate constant at different temperatures given at 27 degrees Celsius and at 3 degrees Celsius. The values are 1.5 and 4.5 10 to the power of 10 to 4.5 10 to the power of 3 respectively. If the activation energy is 60, then find the temperature. So it can be solved based on Arrhenius equation, that is K is equal to A into e to the power of minus EA by RT. So at T1 temperature, if it is K1, at a T2 temperature rate constant will be K2. Therefore, K1 is equal to A into e to the power of minus EA by RT1. Activation energy does not depend on temperature, so we are taking that one same in both the cases. Arrhenius factor also does not change, only temperature and rate constant will change. So if you take logarithm for this, it will be ln K, which is equal to ln A minus EA by RT. So when you substitute different temperatures, so it will be ln K1 is equal to ln A minus EA by RT1, ln K2 is equal to ln A minus EA by RT2. This is 1 and this is 2. So 2 minus 1, if you do it, you will be getting ln K2 by K1, which is equal to EA by R to 1 by T1 minus 1 by T2. So ln K2 by K1 from the value is 4.5 into 10 to the power of 3 by 1.5 to 10 to the power of 3, which is equal to, activation energy is given in kilojoules. So don't hurry here, you should convert that into joule. So 10 to the power of 3 by 8.314 into 1 by T1. T1 is 27 means 300 Kelvin, 1 by T2, that is 273 plus T. So that is ln 3, which is equal to some 60 into 10 to the power of 3 by 8.314 and 1 by 300 minus that 1 by 273 plus T. ln 3 is log 2.303 log 3. Log 3 value approximately you can take 0.48 and solve. Then final answer I am writing, you will be getting that T will be around 41 degree Celsius. So remaining questions will be discussed by our colleagues. Catch you soon.
From mole concept, 18 gram of H2O reacts with X gram of iron to produce Fe3O4. X is the atomic mass of iron is given, which is equal to 56 U. So first we write the reaction taking place. Fe reacts with water, so it will displace hydrogen gas. So it is not reacting under normal condition. I think that there is heating effect, then only it is going to react. The product is Fe3O4 and there is formation of hydrogen in gaseous state. We can balance this reaction. For balancing of iron, we should multiply here by 3, and then for oxygen we should multiply here by 4. In order to balance hydrogen on the left and right hand side, it should be 4 molecules of hydrogen gas. So according to the balance reaction, we can write that the number of moles of iron upon the number of moles of water, that is equal to 3 by 4. The number of moles of iron from here can be calculated since 18 gram of water is there. So 1 mole of water is there. So number of moles of iron needed is 3 by 4. So the mass of iron can be written as 3 by 4 into atomic mass 56. On simplification, we can write that this will be 14 times. 14 into 3 is 42 gram, right? So if we go through the options, third is the correct answer for this. So again, a very simple question based on mole concept, provided you are able to write the reaction. Moving to the third question, this is a question from ionic equilibrium. The KSP values of Ag2CrO4 and AgBr are 32x and 4y respectively. Ratio of solubilities of S1 upon S2, where S1 is the solubility of Ag2CrO4 and S2 is the solubility of AgBr. So again we can write here for Ag2CrO4 the relation between solubility product and solubility. We know that when Ag2CrO4 dissociate, it will form 2 times of Ag plus ion in aqueous state and CrO4 2 minus ion in aqueous state and 2 times of S1, and this is equal to S1. So we can write the relation that the Ksp is equal to 4S1 to the power 3. The value of Ksp is given here. For Ag2CrO4 the value is 32 times of X. So if we simplify, we can write that S1 to the power 3 is equal to 8 times of X, or S1 is equal to 2 times of X to the power 1 by 3. Similarly, for silver bromide, we can write the reaction AgBr in solid state is in equilibrium with Ag plus ion in aqueous state plus Br minus ion in aqueous state, and from here we can write that Ksp is equal to solubility 2 square. So S2 square we can write, and from here the Ksp value is given, that is equal to 4 times of Y. So 4 times of Y is equal to S2 square, or the value of S2 is equal to 2 times of Y to the power half. And they are asking that what is the value of S1 upon S2, which is equal to 2 is common, that will cancel out. So we can write X to the power 1 by 3 divided by Y to the power 1 by 2. Y to the power 1 by 2. So if we go through the options, we are getting that second should be the answer for this. Second will be the answer for this. Moving to the next problem. An angular momentum of electron in nth shell of hydrogen atom is 3h upon pi. The total energy of electron is, so we know that for single electron system, according to Bohr's theory, orbit angular momentum should be integral multiple of h upon 2 pi. So here the value is given, this value is equal to 3h upon pi. So if we cancel out h and pi on both sides, from there we are getting that the value of n is equal to 6. Energy of electron in nth orbit for a single electron system can be written in terms of electron volt as 13.6 Z square upon n square electron volt per atom. So the value of Z is 1 here for hydrogen atom, and we have calculated orbit number is 6. So the answer should be 13.6 divided by 36. So for this you have to do the calculation. On calculating, we are getting this value is 0.377. Now if we write up to 2 decimal place, the value will be 0.38 minus 0.38 electron volt. So from here again we are getting 1 as answer, and this is also a very simple question of atomic structure. So till now whatever the questions we are getting, they are very direct questions, easy calculations also. Moving to the next problem, this is a very good question regarding coordination complex. So arrange the following complexes in increasing order of crystal field splitting energy. So we know that this crystal field splitting energy delta naught depends on many factors, like it depends on the central atom, it depends on the charge on the central atom, right, and it also depends the type of ligand present and the coordination number also. So here if we go through all the options, the central atom is same, that is chromium. In all the options, chromium is the central atom. If we calculate the oxidation state, here it also depends on oxidation state. Here charge on central atom means oxidation state of the central atom, and in all the cases chromium is present in +3 oxidation state. Here also it is in +3. So in all the option chromium is present in +3 oxidation state. Now ligand will decide that which has more value of crystal field splitting energy, right? So many of you will go for B option, because we know that in a spectral chemical series, fluoride ion is a weak field ligand, like halogens are there, then oxygen family is there, and then nitrogen family is there, and then carbon family is there. Now in case of nitrogen family, there is a monodentate ligand NH3, and there is a bidentate ligand ethylene diamine. If you go through a spectrochemical series, right, the field strength may be, if you go through it, because here there is a chelation because of ring formation, the crystal field splitting energy of D option will be greater than C option. So the least value is for B option, and then it is for C option, and then D option, and the highest value is for the A option, right? So this should be the order for crystal field splitting energy. It is based on the field energy of ligands. So if we go through the options, we are getting the first option as answer, right? So it's also very good question based on coordination. Many of you can do error while choosing the C option and D option. Here the donor atom is of same type, that is nitrogen is the donor atom, but in case of D option, due to chelation, it has more crystal field splitting energy. So it's a good question from coordination complex. Now moving to the next problem. Which compound give apple green color in flame test? So very simple question, right? First option will give you the answer, because you know that barium is going to give green color in flame test. So direct question. Moving to the next problem. In isobaric reversible process on a diatomic gas, ratio of Q delta U W shall be, right? So they are not saying that the process is expansion or the process is compression, right? So we can take any one of that. In the option they have given the magnitude of W, means if it is an expansion, then we know that on expanding isobarically the volume is going to increase, means the temperature is going to increase there, because pressure is constant, volume is directly proportional to temperature. So if we write Q, heat energy exchange at constant pressure, can be written as N into Cp into delta T, and ideal gas participating in any process, we can write that change in internal energy is equal to NCV into delta T. And in case of isobaric process, if we write work done, the work done is equal to minus NR delta T, but here we have to write magnitude of work done. So this is magnitude of minus NR delta T, and now we can compare. So ratio of QP is to change in internal energy is to magnitude of work done. If we simplify this value will be, Cp value will be, for diatomic gas it is 7R by 2, so 7R by 2, and Cv, because N, R and delta T is common, that will cancel out. So I'm putting here, okay, R Cv we are, N and delta T we have cancelled, so putting the value of Cp, Cv will be for diatomic gas 5R by 2, and here for work done this R will be there, so R will cancel out, and then on simplification we can write that 7 is to 5 is to 2. So again here we are getting one option is the answer for this very simple question on thermodynamics. Moving to the next problem. The next problem, again it is related to atomic structure, very simple problem for single electron system, because lithium 2 plus is a single electron system. From there we are removing one electron. So we are talking about the ionization energy of a single electron system, which can be written as minus 13.6 Z square upon N square electron volt per atom. So calculating the ionization energy, here it should be positive sign, it is minus times of energy in nth orbit. So if we put the value, this is equal to 13.6, the value of Z square for lithium Z is 3, so Z square will be 9 divided by 1, because lithium in ground, lithium 2 plus in ground state has electronic configuration of 1s1. So N is equal to 1. If we multiply 13.6 into 9, we are going to get 122.4 electron volt per atom. So from here we are getting that the second option is the answer for this. Now we are moving to the next question. Okay, so the next question will be discussed by my colleague. So that is it. Thank you very much. So we can see that the paper relatively is very direct. This paper is, we can say, we can consider it is easy paper with respect to physical chemistry.
Good morning, everyone. Once again, here we are to discuss JEE Main's second shift, second attempt, and April attempt. Today we had first exam. Hope you guys have done very well, and students who are eager to write your upcoming efforts attempts, you can focus we'll be discussing few questions here. Okay, here we have a few questions on memory based, and the first question is from differential equation. Once again, a very easy question from differential equation. If you look at the question, 1 plus sin x dy by dx plus, one moment, yeah, dy by dx plus cos x is equal to 0. So guys, this is a basic variable separable form. You could easily separate the variables of x and y. So, and here we only have in terms of x. So I could write this one, dy by dx is equal to minus cos x by 1 plus sin x. And even the integration part is also a very basic one. So if you clearly see this, if I substitute it as some t, and the numerator is going to be its derivative. So put 1 plus sin x is equal to t, and cos x dx is going to become dt. So this dy is equal to integration. So this is going to become minus dt by t. Integrating on both sides, y is equal to minus ln t, which is 1 plus sin x, plus c, where c is an integration constant. Okay, and the condition given here, f of 0 is equal to 0. So 0 is equal to minus ln 1 plus c. As once again, ln 1 is 0, so c is equal to 0. So the function is going to be y is equal to, or f of x is equal to minus ln 1 plus sin x. So he is asking us to find f of pi by 2. F of pi by 2 is equal to, so sin pi by 2 is 1, so ln 2 minus ln 2. So very fundamental question, minus ln 2, similar to on your board exam style question. Okay, one could easily solve this question. Okay, so we'll move on to next question, which is again from the topic of ellipse. So, and keeping the trend as usual, like whatever he has been asking from the past years, especially from 24-25, and even the first phase of our 26 mains, the similar type of questions were there everywhere. So he is telling that eccentricity of this ellipse is root 5 by 3. So E is equal to root 5 by 3, and the equation, this ellipse passes through this point 3 comma 4. So right away is giving us one equation in B and A. So 9 by a square plus 16 by b square equal to 1. So this, if I expand this, 9b square plus 16a square will be equal to a square b square. So guys, once again, there's a condition in E, eccentricity. So if you recall the formula of eccentricity for an ellipse, b square by a square is equal to 1 minus e square. This would again lead us to b square by a square equal to 1 minus 5 by 9. So this would be b square by a square is equal to 4 by 9, and 9b square is equal to 4a square. Now I have two equations in a square and b square. So if I solve them, I'm going to get a square and b square as well. So here I'm going to substitute this in this equation. So again, it should give me 9b square, which is again 4a square, plus 16a square is equal to a square into b square is equal to 4a square by 9. Okay, basic, again you're just simplifying two equations to get a square and b square. So a square cancel out, 20 is equal to 4a square by 9. So a square will be equal to, could see here 5 times a square is equal to 9 5s are 45, and based on this, if I substitute here, I'm going to get b square is equal to 4 into 45 by 9, which is again 20. So he's asking us to find the length of the lattice rectum. So what will be the length of the lattice rectum of this ellipse? 2b square by a, which is again 2 into b square is 20 by a is root 45. Root 45 is 3 root 5. So this, if you multiply, if you rationalize this, depending upon what are given in the options, you can go through it. Root 5. So this is 5 4s are 20. So this would be 8 root 5 by 3. So the length of the lattice rectum of this ellipse is going to be 8 root 5 by 3. So we'll move on to the next question. It is from chapter permutations and combinations, once again based on number theory. Number of 7-digit numbers formed by using the digits 1, 2, 3, 4, 5 at least once. So he's asking every digit has to used in that 7-digit number at least once. So 1, 2, 3, 4, 5, 6, 7. Guys, anyway, so 1, 2, 3, 4, 5 has to be present in every 7-digit number. Now what about these two positions? These two selections. Now I can make them of two patterns where both of them are equal and both of them are distinct. Suppose case 1, when both are same. Both are same. So what if they are both are 1, both are 2, both are 3, and so on. So how many cases are there? 5 cases. 1, 2, 3, 4, 5. And now for each case, whenever I say suppose 1 and 1 are selected for these two places, now think about how many arrangements we can make. So we have 7 digits, 7 factorial arrangements divided by, out of them 1 is already here and 2 are repeated, so 3 factorial. These are 3 factorials for the repetitions, identical objects here which are 1, 1, 1. There are 3 such things, and this is for one case, and there are 5 such cases. So this will be 5 into 4, 5, 6, 7. So this is 20, 100, 600, 4200. This is case 1. So what about case 2? Case 2, where these digits 1, 2, 3, 4, 5, and these two places can be two distinct digits. They can be 1, 2, 2, 3, 1, 3, and so on. So how many such cases? 5, C2. From 5 we are going to select any 2. And now let us talk about the arrangements we could make. Suppose for an instance, if I take 1 and 2 here, so I have 7 letters, 7 digits, out of 2 of them are repeating twice. So number of arrangements would be 7 factorial by 2 factorial into 2 factorial. So 5C2 is basically 10, 7 factorial, it's 120 into 6 into 7 by 4. So this is 30, 300 into 42, 0, 0, 6, this would be 12. So this is one thing, this is other thing, case 1, case 2. So total sum would be 16,800. Okay. So if you have a moderate proficiency in counting, you could easily solve this question. Okay, we'll move on to next question. So this is from trigonometric equations. He's talking about a trigonometric equation is equal to a, where a has to be integers. So first let us try to find the range of sin x into sin x plus cos x. So this is sin square x plus sin x cos x. So I am going to write this as 1 minus cos 2x by 2, and if I multiply it, this will become sin 2x whole divided by 2. Now he is talking about this being a, where a belongs to integer. He is talking about the integers in the range of this expression. So this will be, you could easily see what is the range of this expression. One could easily recollect the formula. What is the range of a cos x plus b sin x, which is minus root over a square plus b square to root over a square plus b square. Yeah, if you apply the same thing here and add 1 to it, so I would get root range as 1 minus root 5 to 1 plus root 5, where we have denominator mein 2. So guys, this would be around approximately minus 1 point something by 2, and this would be 2 point something by 2. Once again, the integers in this, so we are only looking for integers here. The right hand side of this equation has to be integers. So now in this interval, now see how many integers we have. One could clearly see there are only 2 integers. So a can be either 0 or 1. Now when a is equal to 0, so sin x into sin x plus cos x is equal to 0. So guys, sin x can be 0. How many? Now you could see in minus pi to pi, from here minus pi to pi. How many, for how many values of x sin x is going to become 0? It is 0, pi and minus pi, sin x being 0. What about sin x plus cos x is equal to 0? Sin x plus cos x equal to 0 implies tan x is equal to minus 1. Now how many solutions do we have for tan x is equal to minus 1? So we have minus 3 pi by 4 and minus pi by 4. Okay, so both are in the interval. So here we got 5 solutions in the first case. Okay, so what about the second case? What do we have it in second case? Second case is when sin x into sin x sin square x plus sin square x plus sin x cos x is equal to 1. So guys, if it goes this side, this will become sin x cos x is equal to cos square x. Now if I cancel out cos x, we want to consider solutions of cos x is equal to 0. At the same time, tan x is equal to 1, because sin x is equal to cos x, which means tan x is equal to 1. So tan x is equal to 1 will give us solutions pi by 4. So here I think this is plus 3 pi by 4. It has to be minus 1. Tan x has to be minus 1. Tan x is equal to 1 will be pi by 4 and minus 3 pi by 4. And what about cos x is equal to 0? For cos x is equal to 0, we have pi by 2 and minus pi by 2. So here we have 5 solutions and here we have 4 solutions. So total number of solutions for this, there are 9 such elements in set S which satisfies this condition where A has to be integer. So the solution would be 9. Okay, slightly tricky question, but people who have very strong basics could easily do this question. Go to the next question. Next question is from definite integration. Are not too complex, because if you see step x, whenever you see step x is a piecewise function, and when you are integrating discontinuous function, you have to split the integral. Okay, so one could easily see where to split the integral for greatest integer function is from one integer to the other next integer. So I'm going to split this interval as 0 to 1, 1 to 2 and 2 to 3. So 0 to 1, step x will become 0, 0 factorial is 1. So this will be e power x plus e power minus x. And 1 to 2, step x will be 1, 1 factorial is again 1. So I'll have same thing, e power x, e power minus x dx and dx here, plus 2 to 3, we have 2 in the denominator. So e power x plus e power minus x by 2. So since limits, the function is same here, I'll just add up the limits and integrate it. E power x minus e power minus x, limit starting from 0 to 2, plus e power x minus e power minus x by 2, limit starting from 2 to 3. So we have e square minus e power minus 2. When you put e power 0, e power 0 is 1, 1 minus 1 is 0. So I'm going to get this thing here, and then 1 by 2 into, I'll have e power 3 minus e power minus 3 minus e power 2 plus e power minus 2. So if I combine this whole thing, I'll be getting 1 by 2 into 2 e square minus 2 e power minus 2 plus e cube minus e power minus 3 minus e square plus e power minus 2. So what would this be finally? 1 by 2 into 2 e square minus e square is e square, this one e square, and e cube, there is only one term, e cube minus e power minus 3, and here we have minus e power minus 2. So this should be the answer for this question. Once again, a basic definite integral question involving greatest integer function and factorial as well. Those factorial is just to confuse you. Okay, I mean make you scared that this is a difficult question, but if you understand definite integrals, you can easily split it and step x will not be there, and the factorial also you can write 1 to 2, step x is going to be 2, 2 factorial is once again 2. So once you split the interval, this question is going to be very easy. So we'll move on to next. And once again, question from theory of equations, quadratic equations involving roots. is telling roots of a given equation are alpha and alpha plus 2. Okay, one could see here this, if I expand this question, x square, see here I have x square, x square, x square, so on, I have nx square, quadratic equation nx square, and plus x into, what is the coefficient of x, 2 plus 1 plus 3 4 and so on. Finally sum of these two elements will be 2n, so on 2n. And what about the constant 2? So there is no constant in the first term, so it will be 1 into 3 plus so on, and what will this be, last term n minus 1 into n plus 1, and that is 4n as well here, minus 4n is equal to 0. So once again n into x square plus, if I take 2 common from here, 2x into, this will be sigma n, 1 plus 2 plus 3 so on n, which is n into n plus 1 by 2 plus, for this I am going to apply sigma for n square minus 1 minus 4n is equal to 0. Okay, so here I am going to get nx square plus n into n plus 1x plus, guys, sigma n square will be n into n plus 1 into 2n plus 1 by 6 minus, what about 1, sigma 1 is n minus 4n is equal to 0. Once again I am going to write this nx square plus n into n plus 1x plus, now if I take n common here, this would be 2n square plus 3n plus 1 minus, and this, since we took n common from this whole expression, this is 5 minus 30 by 6 to 0. Okay. So if I take n common and cancel out, I have x square plus n plus 1 into x plus 2n square plus 3n minus 29 by 6 is equal to 0. This is the final quadratic equation which I get here. It is given that sum of the roots, I mean the roots are alpha and alpha plus 2, and he is asking about 2 alpha plus n. Guys, let me write the sum of the roots condition here and see if I can match up anything. So I get sum of the roots 2 alpha plus 2 is equal to minus of n plus 1, sum of roots. And now you could clearly see 2 alpha, and this minus n, if it comes this side, plus n is equal to minus 3. So this is what he is asking, not too much. Okay, you don't have to find roots, or you don't have to put product of the roots, all this condition. Okay, from this relation itself one could easily see what he is asking us to find is 2 alpha plus n. Now what is mod 2 alpha plus n? Is going to be 3. So the answer for this one is going to be 3. Once again, question which puts more emphasis on solving a quadratic equation, sequence and series, and sum of the roots condition. If you are having basics in quadratic equations and sequence and series, you could easily solve this question. Okay, we'll go on to next question. Next question, once again trigonometry condition, trigonometry formula based questions. Once again same repeated old model. If you have really learned something from phase 1, shift 1, or the previous year examinations, one could easily solve this question. So this question is sine, if you convert it into degrees, this is sine 10 degree, sine 50 degree, sine 60 degree, sorry, sine 70 degree. So guys, this is sine 10, sine 60 minus 10, sine 60 plus 10. So once again, very famous formula which we ask every student to remember this one. Okay, this will give you easy, quick, I mean 30-second ka answer. You could easily do it if you remember the formula. Okay, so which is sine theta, sine 60 plus theta, sine 60 minus theta, which is 1 by 4 sine 3 theta. So 1 by 4 into sine 3 into 10, which is 30. So you're going to get 1 by 8, as sine 30 degree is equal to 1 by 2. Again, a very easy question. We'll move on to next question. Yeah, so far we have 7 questions. We'll be coming up for the next part. Okay, thank you.
Questions of today's first shift paper. So in this, if you see the question on the screen, you can see, yeah, in isobaric reversible process on a diatomic gas, the ratio of delta Q, delta U and W shall be. So this ratio we have to find. Now, as we know, in case of isobaric process, delta Q, what we can write here, that is delta Q is equal to NCP delta T, and for the diatomic gas the value of Cp we have, that is 7R by 2. So this we can write, this will be equal to N into 7R by 2 into delta T. Now the next term we have, that is delta U, change in internal energy. So change in internal energy, what we can write? We can write for all the process, that is NCV delta T. Delta U, we can write N CV delta T. So that is equal to N into CV value for monatomic gas, that is 5R by 2, that is 5R by 2 into delta T. Now work done. Now work done in case of isobaric process, we have the formula, that is P delta V, or we can write NR delta T. So we can write this will be equal to NR delta T. So the ratio of these three, what we can write, that is delta Q is to delta U is to delta W, that will be equal to, you see in all the cases this NR delta T term will be cancelled. So we can write that is 7 by 2 is to 5 by 2 is to 1, or this you can write 7 is to 5 is to 2. So we can say here the option 1, that is the correct answer for this question. Next question is, for an ideal gas having Cp is equal to 3R and Cv is equal to 2R, find work done by 1 mole of the gas in adiabatic expansion when pressure reduces from 8 bar to 1 bar and initial temperature that is given here, that is 140 degree Celsius. Now the work done in case of adiabatic process, if we write, so we can write delta W, this is equal to minus N CV T final, let us say T2, minus T initial. So here we can see in this one, in this process, what we require T2 and T1. The values of T2 and T1 we need to know here. So what we can write in this, 8 bar to 1 bar pressure change. With that we can relate T2 with T1. In case of adiabatic process equation, we can write T1 to the power gamma upon P1 to the power gamma minus 1 is equal to T2 to the power gamma upon P2 to the power gamma minus 1. This we can write. Now here we can see T2 in terms of T1, easily we can write T2 is equal to T1 into, that is P2 upon P1 to the power gamma minus 1 upon gamma. This we can write. So here if you see in this, we can write T1 into P2 is how much? P2 is 1 bar. P1 is how much? P1 is 8 bar. We can divide these two. Gamma we can write with the help of Cp and Cv. So gamma we can write that is Cp upon Cv is equal to 3 by 2. So this will be gamma minus 1 upon gamma. If you calculate here, gamma minus 1 upon gamma, this will be equal to 3 by 2 minus 1 upon 1 by 2. So this will comes out what? This 3 by 2, sorry, here this 3 by 2. So this will be 1 by 2 upon 3 by 2. So that is equal to 1 by 3. 1 by 2 upon 3 by 2, that is equal to 1 by 3. So we can substitute here, that is 1 by 3. So this temperature will get T2 is equal to T1 by 2. Now this value we can substitute here. So we can write the work done, that is delta W is equal to minus number of moles 1, the value of Cv, that is 2R, into T2, that is T1 by 2, minus T1. So here you can see this will be minus T1 by 2. So minus minus plus. So that is 2R into T1 by 2, that is RT1. Now T1 value, that is 140 plus 273, that is 314. So 403 in Kelvin we can substitute over here. So we'll get the work done, delta W, that is 413 R. So this is the answer for this problem. The next problem we see here, this is related to the wave optics chapter. In this, given that in YDSE experiment, wavelength of light used is 620 nanometer and separation between slits is 0.2 millimeter. Find the angular fringe width. So angular fringe width, what we can write? We can write delta theta angular fringe width. This is equal to lambda by d. The value of lambda is given here, that is 620 into 10 to the power minus 9 meter upon 0.2 into 10 power minus 3. This is the value of small d. So from here we'll get the value of angular fringe width. If you solve it, we'll get this value, 3.1 into 10 power minus 3. Now the next question is related to the photoelectric effect chapter. Given that photons of wavelength lambda and 3 lambda incident on metal surface, if stopping potential for the ejected photoelectrons are respectively 4V0 and V0, find the threshold wavelength. So if we relate the stopping potential with the work function, so what equation we can write here? We can write E V0, where V0 is the stopping potential, E, capital E is the energy of the photon incident on the surface, minus W, that is the work function. So for the first case, the potential is what? Stopping potential is 4V0. So equation we can write 4E V0 is equal to E, that is Hc by lambda, minus Hc by lambda naught, threshold wavelength, which we want to calculate in this problem. Now the next equation we can make, when the wavelength is 3 lambda, then stopping potential is V0. So equation we can write E V0 is equal to Hc by 3 lambda minus Hc by lambda naught. This is the second equation. Now the value of EV naught from this second equation, we can put it in the first equation. So we can write here 4 in bracket Sc by 3 lambda minus Sc by lambda naught is equal to Sc by lambda minus Sc by lambda naught. And if we simplify this, we will get 4 Sc by 3 lambda minus Hc by lambda is equal to 4 Hc by lambda naught minus Hc by lambda naught. And from here, we will get the value of lambda naught. It comes out what? If you see here, if you solve this one, 4 by 3 minus 1, so that is Sc by 3 lambda is equal to 3 Sc by lambda naught. So lambda naught is equal to 9 lambda. So that is the answer for this problem. The next question we have from the surface tension chapter. Find change in surface energy if 512 small drops of radius r is equal to 2 millimeter merge into a single large drop, surface tension S. So here if you see, if we combine the number of drops, then the radius of the large drop we can calculate with the help of the volume conservation. So we can write initial volume, that is 512 into 4 by 3 pi small r cube. So this is the initial total volume. Now the final volume I can write here, this will be equal to 4 by 3 pi capital R cube, and here capital R is what? That is the radius of the large drop. So from here we'll get the result what? R is equal to 8 small r, and small r is 2 millimeter. So this is equal to 16 millimeter. So this is the radius of the large drop. Now what we have to find, that is a change in surface energy. So change in surface energy, we can write delta U. So we have to calculate the magnitude only. So I can write this will be delta U mod, that is equal to S surface tension into change in surface area delta A. So we can write S into 512 into 4 pi small r square is the initial surface area of the system. We have 512 small drops. For one drop, single drop, surface area is how much? 4 pi small r square. And finally, what surface area we have? That is 4 pi capital R square. We have a large drop, single large drop of radius capital R. Now we can substitute the values in this. You can see here 4 pi, that will be common, into S, in bracket we can write 512 into small r, that is 2 millimeter. So you can write 2 upon 1000 meter, and this square minus capital R 16 millimeter. So 16 upon 1000 whole square. So if you solve this one, so this value comes out is equal to, that is pi s into 7.168 into 10 power minus 3 joules. So this is a answer for this particular problem.
Yeah, here is your another question. In this, he clearly mentioned list one, ethanol, phenol, ethanoic acid, and acetaldehyde. We have to match with a qualitative test given by that particular compound. So here we have ethanol. Ethanol, since it is alcohol, the suitable option for this, it will give steric ammonium nitrate test. Continuation. So ethanol will give steric ammonium nitrate test. Therefore, the suitable option for this will be Q. Phenol, it will give positive results in neutral FeCl3 test. So the correct option will be P. Ethanoic acid will decompose the sodium bicarbonate. It will give NaHCO3 test. So the correct answer will be S. And acetaldehyde, it will give Schiff's reagent test. Therefore, it will be R. So the correct option will be ethanol Q, phenol P, ethanoic acid S, acetaldehyde R. So that particular option will be 3. So this is the question from organic chemistry functional group tests. And the next question, if you see, isopropyl benzene, also known as cumin, that is in presence of sunlight treated with oxygen, later that is treated with acidulated water. If you can recollect, this particular reaction is used for the preparation of phenol and acetone. Exactly, if you can recollect the product, this is isopropyl benzene. On reaction with oxygen in presence of sunlight, it will give cumyl hydroperoxide. The structure of this cumyl hydroperoxide will be this one. Later, when it is treated with water in presence of acid, that will give you a final product, that is phenol, and another organic compound produced will be acetone. So that is CH3, C double bond O, CH3. So phenol and acetone. So the answer to this question will be 3. And the next question, here two statements are given. First statement is related to first ionization enthalpy. The elements given here are sodium, magnesium and aluminum. The first statement is related to first ionization enthalpy and second statement is related to second ionization enthalpy. So here these are one period elements. So here sodium, magnesium and aluminum. In case of, in general, left to right ionization enthalpy increases, but in case of magnesium and aluminum, due to stable electronic configuration, fulfilled electronic configuration of magnesium, ionization enthalpy of magnesium is greater than aluminum. So left to right ionization enthalpy increases, but only from magnesium to aluminum the value will decrease. So based on this, the correct order of ionization enthalpy will be, first ionization enthalpy will be magnesium followed by aluminum, next it will be sodium. This is the first ionization enthalpy of these three elements, but here he mentioned sodium, magnesium, aluminum, therefore statement 1 is wrong. And second ionization enthalpy, we have to remove electron from unipositive ions. So here sodium, magnesium, aluminum, three elements, but we are taking second ionization enthalpy. For that we have to take a unipositive ion, Na plus, Mg plus, Al plus. Na plus, the configuration will be neon configuration. Mg plus, the configuration will be sodium configuration. Al plus, the configuration will be magnesium configuration. These are the configurations possessed by unipositive ions of sodium, magnesium, aluminum. Very clear, neon, due to the stable electronic configuration. In these three configurations, neon configuration has more ionization enthalpy. That neon configuration is possessed by sodium. So in case of second ionization enthalpy, sodium should have highest, but according to the given option, magnesium is given highest. Therefore this statement is also wrong. So the suitable option will be both statement 1 and statement 2 are incorrect.
Hi everyone, this is Subramanyam, Mathematics Faculty, Narayana Group. Already 7 questions are completed in this shift. The 8th question is, let f of x is equal to mod sin x upon x when x is not equal to 0, 1, x is equal to 0. Then total number of critical points in the interval minus 2 pi comma 2 pi they asked. The question is related to the continuity and differentiability and also differentiation, because here the total number of critical points they asked. The total number of critical points they asked means definitely here critical points definition. First, we need to recall the critical point definition. The critical points means where the derivative of the function f of x is 0 and the derivative does not exist, commonly known as the critical points. So first of all, we are going to check the differentiability concept here. The given function f of x is equal to mod sin x by x when x is not equal to 0 and 1 when x is equal to 0. First, to check the differentiability, here we have one property, that is mod g of x is non-differentiable if g of x is equal to 0, and where the g of x is equal to 0 gives all those are the doubtful points for the differentiability. So in the case of in this problem, g of x is equal to sin x by cos x. G of x is equal to sin x by cos x. So sin x by cos x is equal to 0. It implies sin x is equal to 0. So the doubtful points are x is equal to 0, comma, pi, comma, minus pi are the doubtful points. At these points, the function may not be differentiable. First, we are going to check at x is equal to 0, whether it is differentiable or not. If the function is not differentiable, then definitely it is one of the critical point. So to check the differentiability condition here, first at x is equal to 0, I am going to check the function f is differentiable or non-differentiable. We have the formula f dash of 0 is equal to f of h minus f of 0 by h whenever limit h tends to 0. This is f dash of 0. F dash of 0 is equal to limit h tends to 0, f of h minus f of 0 upon h. Now this is equal to limit h tends to 0. F of h means here when x is not equal to 0, the function is defined as sin x by x. Hence, we are writing this one as sin h by h minus f of 0 becomes here f of 0 is equal to f of 0 we are going to check. F of 0 means limit x tends to 0. Limit x tends to 0 f of x, that becomes as 1 by h. Now this is equal to limit h tends to 0 sin h minus h upon h square. When we are applying the limit to this expression, the numerator and denominator takes the forms 0 by 0 form. So we are applying the L'Hopital rule. By applying the L'Hopital rule, limit h tends to 0, we are applying the L'Hopital rule, or we are using here in this case the expansion is also correct. The expansion I am using sin h expansion is h minus h cube by 3 factorial minus h upon h square. Now this is equal to limit h tends to 0. This becomes as minus h by 6 is equal to 0. This one is equal to 0. In this case, at x is equal to 0, the function is differentiable. Fy is differentiable, but the derivative of the function at x is equal to 0 becomes 0. By the definition of the stationary point, here x is equal to 0 is also a critical point. F dash of 0 is equal to 0. It implies x is equal to 0 is a basically stationary points. Stationary point. So x is equal to 0 is a stationary point. It is a stationary point. Stationary. Every stationary point is also a critical point. Now we are going to check at x is equal to pi and at x is equal to minus pi whether the function is differentiable or not. It is very clear at x is equal to pi and at x is equal to minus pi, f of x is non-differentiable. You know these very well. Non-differentiable. Suppose if you want to check at x is equal to differentiability, at x is equal to pi, the differentiability of the function f of x, same process what we can done in the at x is equal to 0, in the same process you try to solve the problem. Then we are getting definitely it is f of x is non-differentiable at x is equal to minus pi comma pi. So these two are also the critical points. So At these 2 points, the function is not differentiable. These 2 are the critical points. Total 3 critical points here. Now, f dash of x is equal to 0. We are going to find out f dash of x is equal to 0. That is, f dash of x is equal to, we are differentiating with respect to x, sin x by x. Sin x by x. Now, the derivative of sin x by x, using the u by v rule, we are writing this one as x square, x cos x minus sin x. So, f dash of x is equal to 0. It implies x cos x minus sin x is equal to 0. From this, tan x is equal to x. Tan x is equal to x. F dash of x is equal to 0 means tan x is equal to x. Now, how many solutions it has in the interval minus 2 pi to plus 2 pi? That we are going to check. That is, by using the graph, we get this one. See there? I am going to draw the graph of tan x is equal to x graph. In the interval 0 comma 2 pi interval, I am going to draw. This is pi, and suppose this is pi by 2. Next 3 pi by 2 and 2 pi. This is 2 pi. Now the tan x graph is, you know that how we are going to draw the tan x graph means like this one. Like this one. Now by drawing y is equal to, here we are going to draw the graphs of y is equal to tan x and y is equal to x. Y is equal to x line. This is y is equal to x. Therefore, tan x is equal to x has a solution in one solution in 0 comma 2 pi. Similarly, by the symmetricity of the function, because this function is a symmetric function, observing f of minus x is equal to f of x. F is a symmetric function. F is a symmetric function. F is a symmetric function. Hence, there exists one more root for tan x is equal to x. One has one solution. In the interval 0 comma minus 2 pi. Therefore, f dash of x is equal to 0 has two solutions in minus 2 pi comma 2 pi interval. Hence, the total number of critical points, total number of critical points is equal to, first 0 is 1, plus pi and minus pi are the critical points 2. Here f dash of x is equal to 0. F dash of x is equal to 0 has 2. Total 5 critical points the function. The problem contains multiple concepts. Definitely, it is somewhat lengthy problem, and the differentiability checking and also the derivative of the function must know the student. Then only he can handle this problem. Next problem. Consider two APs such that AP1 has first term 1, common difference 5, and total terms 101. And second AP has first term 9, common difference 7, and total terms 71. Then the number of common terms which appear in both these APs they asked. This type of problem frequently in JEE Mains NTA persons were asked. So it is a standard model question. First we are going to find out the sequence, the first AP we are going to find out. For the first sequence, the number of terms, suppose n1. n1 is equal to 101, and first term a is equal to, a is equal to 1, and first common difference d1 is equal to 5. So here the First sequence contains 101 terms, and nth term formula we know that the nth term formula is Tn is equal to A plus n minus 1 times of D. Now this is equal to A is 1 plus n minus 1 into D. From this, if n is equal to 101, then 101 term becomes as 1 plus 101 minus 1 into D1 is equal to 5 here. D1 is equal to 5. Suppose I consider this one as A1 you consider. Now this is equal to the 101 term becomes as here is 100, 500, 501. It is 501. 501. 101, the term in the first AP is 501. Similarly, for the second AP, and the sequence becomes as the first term is 1, second term is the common difference is 5, hence 6, next one is 11, next 16, next 21, and so on, 501. This is the first AP, AP1, AP1. Similarly, we are going to write the second AP also. Second AP, for the second AP, nth term I am writing is equal to, for the second AP, the first term is 9 plus n minus 1 into common difference is 7. Common difference is 7. Suppose the sequence has 71 terms, that is, by substituting n is equal to 71, T71 is equal to 9 plus 70 into 7 is equal to 499. 499. 71th term is the 499. Now, observing the sequence becomes as the first term is 9, common difference is 16, that is common difference is 7, 16, comma 23, comma 30, and so on. The last term is 499. This is the AP2. Second AP. The first AP is 1, common difference 5, so 6, third term 11, fourth term 16, and 21, and so on. The last term is 501. This is the first AP. AP1 this is. Now, we want the common terms in these two APs. That is the first common term observing, it is 16, here also 16. So, we start with the first term of common terms is 16. Now, common difference here, LCM we consider. LCM of first sequence common difference is 5, second sequence common difference is 7, is equal to 35 is the common difference. 35 is the common difference. Now, here kth term should be less than or equal to the least of the term in the two APs, that is 499. Tk, we have the formula, that is first term 16 plus k minus 1 into d is 35 is less than or equal to 499. From this, we are going to calculate the k value, how many terms it has means. So, here k minus 1 times of k minus 1 times of 35 is less than or equal to, this becomes as 483, and from this k minus 1 is less than or equal to 483 upon 35. It is 35 division 13.8. So from this k is equal to 14.8. K is less than or equal to. Therefore, the number of terms common is 14. The number of terms common is 14. This is very regular problem. Problem level is easy problem. Next, third problem. if 36CR plus 1 is equal to 6 times of 35CR k square minus 3, such that S is equal to set of R comma ordered pair R comma K, then the number of elements in set S they asked. So the problem is related with the binomial coefficients as well as here the number of elements we are going to calculate. So related to the sets and relations. First of all, 36CR plus 1 is equal to 6 times of 35CR upon K square minus 3. 36CR plus 1 is an integer, hence 6 into 35CR by K square minus 3 is also an integer. So here 35CR by K square minus 3 is an integer, means definitely K square is also an integer. Then only the given equation is defined. K is also an integer. Next, it is based on recurrence formula of the binomial coefficients. Recurrence formula of the binomial coefficients means the basic formula is NCR is equal to n by R times of n minus 1 C R minus 1. By using this one, the problem is very simple. See there, in the LHS 36CR plus 1. 36CR plus 1. That 36CR plus 1 I am going to be write as 36 by R plus 1 into 35CR is equal to 6 times of 35CR into 1 by K square minus 3. Now it is very clear, 35CR cancelled. From this we get the relation. Here 6 and 36 is here 6. So K square minus 3 is equal to K square minus 3 is equal to 6 by R plus 1. 6 by R plus 1. K square minus 3 is equal to R plus 1 by 6, or K square is equal to 3 plus R plus 1 by 6. K square is equal to 3 plus R plus 1 by 6. Now here 35CR defined. 35CR defined only for 0 is less than or equal to R is less than or equal to 35. 0 is less than or equal to R is less than or equal to 35. And by observing K square is a perfect square and it is an integer, and the RHS is 3 is an integer, and R plus 1 by 6 is also an integer. R plus 1 by 6 is an integer. It is an integer. When it is possible means R plus 1 is a multiple of 6. A multiple of 6. Then R plus 1 by 6 is an integer and K square is also an integer. We are getting. So in this way we are going to fix the R value. R plus 1 by 6 is an integer and 0 is less than or equal to R is less than or equal to 35 means definitely R plus 1 belongs to one of the values. One of the values means here definitely 6 or 12, 6 multiples, 18, next 24, 30. For 30, 30 and one more is there, 30, R is less than or equal to 35. So only R is equal to 30. We are going to check these values. At these values we are going to check. 6 multiples, R plus 1, 36. Everything is clear? I think everything is clear. Now first, one by one we are going to check. That is, suppose R plus 1 is equal to 6. Then K square is equal to 3 plus 1 is equal to 4. It implies K is equal to plus or minus 2. Therefore, ordered pairs R comma K is equal to 5 comma plus or minus 2. In this case, 2 ordered pairs. In this case, 2 ordered pairs. Next one, R plus 1 is equal to, we are going to take 12. If R plus 1 is equal to 12, it implies K square is equal to 3 plus 2. is equal to 5, not a perfect square. Not a perfect square. So there is no such type of integers r comma k. Next, similarly, r plus 1 is equal to 18. R plus 1 is equal to 18. I think there is no value of k. K square is equal to 3 plus 3 is equal to 6. Not a perfect square. R plus 1 is equal to 24. R plus 1 is equal to 24 means k square is equal to 3 plus 4 is equal to 7. Not a perfect square. R plus 1 is equal to 30. K square is equal to R plus 1 30 and k square is equal to 3 plus 5. Not a perfect square. When r is equal to 35, this is final. So when r is equal to 35, k square is equal to 3 plus 6 is equal to 9. It is a perfect square. K is equal to plus r minus, k is equal to plus r minus 3. K is equal to plus r minus 3. Therefore, r comma k is equal to, the possibilities are 35 comma plus r minus 3. In this case, 2 elements. Therefore, S has total 4 elements. Total 4 elements. Total number of elements are 4. Next one. The domain of f of x, square root of log of 0.6 2x minus 5 upon mod x square minus 4 is. It is a regular model problem and the domain square root function. Here the solution for this one, first of all, domain means for what values of x the function is having the real values, those set of values of x is called as the domain of the function. So here first of all, when f of x belongs to R means it is a square root function. Hence, definitely the inside expression is greater than or equal to 0. That is, inside expression means log of 0.6 mod 2x minus 5 upon mod x square minus 4 is greater than or equal to 0, and the logarithms are defined. The logarithms are defined only for the positive numbers. That is, mod 2x minus 5 upon mod x square minus 4 is greater than 0. That is, f of x is real means simultaneously the function satisfies these two conditions. That is, log of mod 2x minus 5 by mod x square minus 4 to the base 0.6 is greater than or equal to 0, and mod 2x minus 5 by mod x square minus 4 is greater than 0. Now it is always true except when the numerator is equal to 0. That is, this is the modulus function. Every modulus function is greater than or equal to 0 the value. When it has the 0 means x is equal to 2x minus 5 is equal to 0, x is equal to 5 by 2. So it is true for all real numbers except at x is equal to 5 by 2. Now we are going to solve the logarithmic inequality. By solving the logarithmic inequality, we get the answers here. So logarithmic inequality, when the base is less than 1, so it changes the inequality. That is, we are getting here the numerator is 2x mod 2x minus 5 mod 2x minus 5 upon mod x square minus 4 is less than or equal to 1. It is less than or equal to 1. Less than or equal to 1. Then only it is defined. So, by multiplying both sides with mod x square minus 4, mod 2x minus 5 is less than or equal to mod x square minus 4. Now, here I am using the mod a is less than or equal to mod b means directly 2x minus 5 is less than or equal to x square minus 4 and 2x minus 5 is greater than or equal to minus x square plus 4. By solving these two inequalities, we get the domain of the function. Now to solve these two, here is x square minus 2x plus 1 is greater than or equal to 0. It implies x minus 1 whole square is greater than or equal to 0. This is true for all real numbers. So, in this case, x belongs to R. Next, the second case is 2x minus 5 is greater than or equal to minus x square plus 4. That is x square plus 2x minus 9 is greater than or equal to 0. Now, it is by doing the perfect square method. Here I am solving this one. That is, here I am taking 9 to the right hand side. That is x square plus 2x is greater than or equal to 9, or I am writing this one as x plus 1 whole square is greater than or equal to 10. Mod x plus 1 is greater than or equal to square root of 10. Now, here is, by opening the modulus here, minus root 10 is less than or equal to x plus 1 is less than or equal to root 10. From this, minus 1 minus root 10, it is greater than or equal to. So, we have the inequality. One inequality I am using here, that is x plus 1 is less than or equal to minus root 10 minus root 10, or x plus 1 is greater than or equal to root 10. So, from this, x is less than or equal to minus 1 minus root 10, or x is greater than or equal to minus 1 plus root 10. Therefore, x belongs to, in this case, minus infinity comma minus 1 minus root 10 union minus 1 plus root 10 comma infinite, minus the function is not defined when x is equal to 5 by 2. It is 5 by 2, it is not defined. By subtracting this one, we are getting. Observing the options, option A is correct. First option is right here. First option is correct. It contains the modulus function concept and also square root function concept. And problem is moderate level problem. Next, go to the problem. Next, go. Here is, if L1 is x minus a by 2 is equal to y minus 2 by 3 is equal to z minus b by 6, and L2 is x minus b by 3 is equal to y minus 7 by 6 is equal to z minus 1 by 3 intersect in xy plane, then the value of mod a plus b they asked here. So, the problem is related to the 3D lines, 3D lines, three-dimensional geometry lines topic. The two lines are given, they are intersecting in xy plane. If the lines are intersecting in xy plane, definitely the z coordinate becomes as 0. The z coordinate becomes as 0 means directly the equation, first equation becomes as x minus a by 2 is equal to y minus 2 by 3 is equal to, by substituting z is equal to 0, minus b by 6, because of here the xy plane equation is z is equal to 0. That's why if the line lies on xy plane, z coordinate should be 0. That's why I am substituting z is equal to 0. Similarly, the second line becomes as, this is the first line, and the second line becomes as x minus b by 3 is equal to y minus 7 by 6 is equal to minus 1 by 3. By solving these two, that is x minus b by 3 is equal to minus 1 by 3 means x is equal to b minus 1 and y is equal to, it is y is equal to 6 is here, minus 2 plus 7 minus 5. Y is equal to minus 5. Y is equal to minus 5. The two lines are intersecting, hence these can be substituted in the first line. By substituting in the first line from L1, x is replaced with b minus 1 minus a by 2 is equal to y is minus 5 minus 2 by 3 is equal to minus b by 6. Minus b by 6. Now from this we get the b value as well as a value, b value and a value by solving. The first, by solving these two, here is Observe here y is equal to plus 5. So this is plus 5. So here minus b by 6 is equal to 1. It implies b is equal to minus 6. Now here I am substituting. Minus 7 minus a by 2 is equal to 1. From this we get the a value. Minus 7 minus a is equal to 2. A is equal to minus 9. A is equal to minus 9. B is equal to minus 6. They asked for the mod A plus B. Mod A plus B. So mod A plus B is equal to mod. The A value is, we know that here mod A value minus A value is minus 9, B value is minus 6. Hence this becomes minus 9 plus minus 6 is equal to 15. Mod A plus B is equal to 15. The problem is very simple problem. Next one. This problem is related with the differential equation. If dy by dx is equal to 2 plus log x has solution y is equal to y of x such that y of 1 is equal to e, then y of e is equal to, they asked. See the differential equation directly by using the variable separable method, we get the solution here. That is, we are writing dy is equal to 2 plus log x to the base e into dx. Now we are differentiating here. By differentiating with by integrating this one, integral dy is equal to integral 2 dx plus integral log x to the base e dx. Now this is equal to 2x plus integral log x to the base e. We have direct formula x log x to the base e minus x plus c. Now this becomes x plus x log x to the base e plus c. This is y of x. Y of x, this is y of x is equal to x plus x log x to the base e plus c. Now they are given since y of 1 is equal to e. If y of 1 is equal to e, that is by substituting x is equal to 1 in this equation, e is equal to 1 plus 0 plus c. So from this, c is equal to e minus 1. C is equal to e minus 1. Now the function becomes as y of x is equal to x plus x log x, x plus x log x to the base e plus c is here e minus 1, e minus 1. This is the function. Now they asked for y of e. Put x is equal to e. By substituting x is equal to e, y of e is equal to e plus e into log e to the base e plus e minus 1. This is equal to 2e plus e minus 1 is equal to 3e minus 1. Therefore, y of e is equal to 3e minus 1. Very simple problem. It is in differential equation. By using the variable separable method, very easily we get the solution. Next one. If mod a bar is equal to 2 and mod b bar is equal to 3 and the angle between a bar and b bar is 60 degrees, then 3 times of mod 3a bar plus 4b bar plus 4 times of mod 3a bar minus 4b bar is equal to, they asked. So here the angle between the two vectors is given 60 degrees and the magnitudes of a bar and b bar vectors are given. That's why it is very easy to find the dot product of a bar and b bar. So we start with the dot product of a bar and b bar. A bar dot b bar is equal to, we have the formula mod a bar mod b bar cos of the angle between a bar and b bar, that is 60 degrees. Now this is equal to mod a bar is 2, mod b bar is 3 and cos 60 is 1 by 2. This is equal to 3. So therefore, a bar dot b bar is equal to 3. A bar dot b bar is equal to 3. Now we are going to calculate the magnitude of 3a bar plus 4b bar. That is mod 3a bar plus 4b bar. So how we are opening the modulus of the vectors means by taking the square. I consider the square of this magnitude is equal to directly 3a bar plus 4b bar whole square is equal to 3a bar whole square. That is, it becomes as 9 mod a bar square, 9 mod a bar square plus 16 mod b bar square plus 2 into 3 into 4, that is 24 times of a bar dot b bar. Now this is equal to 9 times of mod a bar square is 4 plus 16 times of mod b bar square is 9 plus 24 into a bar dot b bar is 3. Now this is equal to 36 plus 144 plus 72. Now this is equal to, the calculation becomes as 252. 252. So from this we get the mod 3a bar plus 4b bar. Mod 3a bar plus 4b bar. See that? Mod 3a bar plus 4b bar is equal to square root of 252. We may write this one as 6 root of 7. 6 root of 7 this is. Next, similarly, mod 3a bar plus 4b bar whole square is equal to, the first terms all are same as in the previous model. That is, I am using this one completely. That is 36 plus 144 minus 72. Now this becomes 108. 108 this is. So mod, here is minus, mod 3a bar minus 4b bar is equal to square root of 108. This is 6 root 3. 6 root 3. Now, what they asked here means 3 times of, now 3 times of mod 3a bar plus 4b bar plus 4 times of mod 3a bar minus 4b bar. Now this is equal to 3 times of 6 root 7 plus 4 times of 6 root 3. Now this is equal to, this becomes as, observing the options, we are going to simplify. So it is in terms of 7 and root 3. That's why directly this is 18 root 7 plus 24 root 3. 18 root 7 plus 24 root 3. That is option second. Second option is right. Second option is right. Problem is very simple, and it is based on only the dot product and mod a bar plus b bar whole square formula. Next, the value of integral 2 to 4 square root of 2 to the power of x minus 4 dx plus integral 0 to 2 root 3 log of x square plus 4 to the base 2 dx is equal to. So here, if anyone try to solve this problem directly, it is very difficult. It is one property based problem, because here if we are observing the logarithmic function I am taking as f of x, if I consider log as f of x as log of x square plus 4 to the base 2. Now I am trying to find out the inverse function of this one, that is when this one is equal to y is equal to log of x square plus 4 to the base 2. So from this, x square plus 4 is equal to 2 to the power of y, and x square is equal to 2 to the power of y minus 4. X is equal to square root of 2 to the power of y minus 4. Therefore, this becomes as f inverse of x is equal to square root of 2 to the power of x minus 4. And moreover, by substituting here x is equal to 0, we get f of 0 is equal to 2. And by substituting x is equal to 2 root 3 in the function, f of 2 root 3 is equal to, by substituting 2 root 3, 2 root 3 whole square is 2 root 3 whole square is 12 plus 4 16, hence this is 4. So the given The given definite integral expression can be written as integral. I consider 0 comma 2 root 3 as a comma b, and the function is f of x dx plus integral, it is f of a, f of b, f inverse of x dx. The given definite integral expression is in the form of integral a to b f of x dx plus integral f of a to f of b f inverse of dx, where if we are observing a is equal to here, a is equal to, it is a is equal to 0, a is equal to 0, and b is equal to 2 root 3, f of a is equal to 2, and f of b is equal to 4. F of b is equal to 4. But this is one of the important property in the definite integration. The value becomes as this value is equal to b times of f of b, times of f of b minus a times of f of a. B is 2 root 3 into f of b is 4 minus a is 0. Now this becomes 8 root 3. 8 root 3. The answer is 8 root 3. That is, observing the options, option 3 is correct. So far we discussed up to 15 problems. All are almost easy to moderate level. The problems are very easy and moderate level problems. So all the best. Good luck.
Good afternoon, everyone. So this is a memory-based JEE Mains April session, a physics question paper. So we have a few questions with us. Let's see. So the first question is about dimensional analysis here. So you can see here this quantity particularly is energy density. So you might remember the formula that energy density in a space where electric field is E in vacuum is equal to half epsilon naught E square here. So if we know that, that will be a very easy one. So energy density is going to be energy which is ml2 T minus 2 divided by volume L3, giving us ml minus 1 T minus 2, which gives us A as 1, B as minus 1, and C as minus 2. Finally, A minus 1, and here A is equal to actually 1 plus C, like that. So we get overall 0 as the answer in this case, as per the given information here. Or you can also put it here, the individual values, but the best way would be to think in terms of energy density. Next question we have. So we have a wooden block already floating in water with some length already inside here. So, and then we are putting a coin over it, and because of which the block goes down further by 0.3 centimeter. So we can apply force balance here. So the weight here is going to be density of the wood, volume, G. Mg is equal to basically equal to density of water, volume displaced here, which is going to be L square into x, where x is the length already inside here, into G. So buoyant force is equal to weight. From here you can see x comes out to be rho wood divided by rho water, density of water, L here, giving us, now this is the relative density, which is going to be 0.4, L is 10 centimeter here, giving us x as 4 centimeter. So 4 centimeter of it was already inside water. Now, because of the weight of the coin, 0.3 centimeter goes down further. So same equation we'll write down, but in this case with the weight of the coin, and this will further go down by 0.3 centimeter. So you can see here, mg is the weight of the coin plus weight of the wooden block is equal to buoyant force. Now buoyant force in this case is going to be L square multiplied by 4.3 centimeter multiplied by g, giving us mg is equal to raw water into 4.3 centimeter minus raw wood L here, and entire thing multiplied by L square g. So density of water in SI units is going to be 1000. We can convert this 4.3 centimeter into meter, which is divided by 100. Minus raw wood is going to be relative density is going to be 0.4. So density of wood is going to be 400 multiplied by 10 centimeter again. L is 10 centimeter, but I have to convert it in meter. So 10 over 100. Now L square is going to be 100 in centimeter square. So I can write it down 10 divided by 100 and convert it into meter and square that multiplied by value of g, which is 10 here. So weight overall comes out to be 43 minus 40 multiplied by 1 over 100 and g value is 10, which finally gives us 0.3 Newton as the weight of the coin. Going to the next question. This is based on calculation of magnetic field at the center. So looking at the direction of current here, so we have three components in both the diagrams, and a right hand thumb rule you can apply to see the direction. So magnetic field, because of the upper part of the current, you can say part 1, part 2 and part 3 here. So because of part 1, right hand thumb rule, the magnetic field is going to be into the page here because of 1. Because of 2 also it's going to be into the page, and because of 3 as well is going to be into the page. So all three parts magnetic field is going to add up in this situation. Same case if you see with the second part 1, 2 and 3. Because of part 1, again the magnetic field is going to be into the page. Because of 2 is going to be into the page, and actually because of 3 magnetic field is going to be 0 because the point lies along the wire here. So total magnetic field in the first situation is going to be the sum of all three. So mu naught I divided by 2 pi r. Now this is the magnetic field of the entire straight wire if it is infinitely long. So I have to do half of that because we have semi-infinite wires, and then again twice because B1 and B3 combined is going to be semi-infinite twice because of that, plus because of circular wire it's going to be mu naught I divided by for entire circle the formula is mu naught I by 2r. In this case for the half circle is going to be 4r. Going further, for this one straight wire mu naught I divided by 2 pi r, half of that, and only half because only half the wire we have, plus mu naught I by 4r, like that. So simplifying that, you can see mu naught I by 4r we can cancel here directly. So this term, this entire term except for pi, this entire term except for pi, and this entire term. So I'm left with 2 over pi plus 1 divided by 1 over pi plus 1. If you multiply and divide by pi, we get pi plus 2 divided by pi plus 1 as the answer, which is the third option in this case. Going further, this here angular displacement is given as a function of time. So theta, as they said, is t raised to the power 4 divided by 4 minus t square, and they're asking for angular acceleration. So omega is going to be equal to d theta by dt is equal to 4 t cube divided by 4 minus 2t, giving us t cube minus 2t. Now alpha is going to be equal to d omega by dt, giving us 3t square minus 2. They're asking for alpha at the time t is equal to 1 second here. So you can put here alpha at 1 second. This is going to be 3 into 1 square minus 2, which gives us 3 minus 2, giving us 1 radian per second square. This is the last question here. Thank you, everyone. Good afternoon, everyone. So this is a memory-based JEE Mains April session, a physics question paper. So we have a few questions with us. Let's see. So the first question is about dimensional analysis here. So you can see here this quantity particularly is energy density. So you might remember the formula that energy density in a space where electric field is E in vacuum is equal to half epsilon naught E square here. So if we know that, that will be a very easy one. So energy density is going to be energy, which is ml2 t minus 2 divided by volume L3, giving us ml minus 1 t minus 2, which gives us A as 1, B as minus 1, and C as minus 2. Finally, A minus 1, and here A is equal to actually 1 plus C, like that. So we get overall 0 as the answer in this case, as per the given information here. Or you can also put it here, the individual values, but the best way would be to think in terms of energy density. Next question we have. So we have a wooden block already floating in water with some length already inside here. So, and then we are putting a coin over it, and because of which the block goes down further by 0.3 centimeter. So we can apply force balance here. So the weight here is going to be density of the wood, volume, G. Mg is equal to basically equal to density of water, volume displaced here, which is going to be L square into x, where x is the length already inside here, into G. So buoyant force is equal to weight. From here you can see x comes out to be rho wood divided by rho water, density of water, L here, giving us, now this is the relative density, which is going to be 0.4, L is 10 centimeter here, giving us x as 4 centimeter. So 4 centimeter weight was already inside water. Now because of the weight of the coin, 0.3 centimeter goes down further. So same equation we'll write down, but in this case with the weight of the coin, and this will further go down by 0.3 centimeter. So you can see here mg is the weight of the coin plus weight of the wooden block is equal to buoyant force. Now buoyant force in this case is going to be L square multiplied by 4.3 centimeter multiplied by G, giving us mg is equal to raw water into 4.3 centimeter minus raw wood L here, and entire thing multiplied by L square G. So density of water in SI units is going to be 1000. We can convert this 4.3 centimeter into meter, which is divided by 100. Minus raw wood is going to be relative density is going to be 0.4. So density of wood is going to be 400 multiplied by 10 centimeter again. L is 10 centimeter, but I have to convert it in meter. So 10 over 100. Now L square is going to be 100 in centimeter square. So I can write it down 10 divided by 100 and convert it into meter and square that, multiplied by value of G, which is 10 here. So weight overall comes out to be 43 minus 40 multiplied by 1 over 100, and G value is 10, which finally gives us 0.3 Newton as the weight of the coin. Going to the next question. This is based on calculation of magnetic field at the center. So looking at the direction of current here, so we have three components in both the diagrams, and a right hand thumb rule you can apply to see the direction. So magnetic field, because of the upper part of the current, you can say part 1, part 2 and part 3 here. So because of part 1, right hand thumb rule, the magnetic field is going to be into the page here because of 1. Because of 2 also it's going to be into the page, and because of 3 as well is going to be into the page. So all three parts magnetic field is going to add up in this situation. Same case if you see with the second part 1, 2 and 3. Because of part 1, again the magnetic field is going to be into the page. Because of 2 is going to be into the page, and actually because of 3 magnetic field is going to be 0 because the point lies along the wire here. So total magnetic field in the first situation is going to be the sum of all three. So mu naught I divided by 2 pi r. Now this is the magnetic field of the entire straight wire if it is infinitely long. So I have to do half of that because we have semi-infinite wires, and then again twice because B1 and B3 combined is going to be semi-infinite twice because of that, plus because of circular wire it's going to be mu naught I divided by for entire circle the formula is mu naught I by 2r. In this case for the half circle is going to be 4r. Going further, for this one straight wire mu naught I divided by 2 pi r, half of that, and only half because only half the wire we have, plus mu naught I by 4r, like that. So simplifying that, you can see mu naught I by 4r we can cancel here directly. So this term, this entire term except for pi, this entire term except for pi, and this entire term. So I'm left with 2 over pi plus 1 divided by 1 over pi plus 1. If you multiply and divide by pi, we get pi plus 2 divided by pi plus 1 as the answer, which is the third option in this case. Going further, this here angular displacement is given as a function of time. So theta, as they said, is t raised to the power 4 divided by 4 minus t square, and they are asking for angular acceleration. So omega is going to be equal to d theta by dt is equal to 4t cube divided by 4 minus 2t, giving us t cube minus 2t. Now alpha is going to be equal to d omega by dt, giving us 3t square minus 2. They are asking for alpha at the time t is equal to 1 second here. So you can put here alpha at 1 second. This is going to be 3 into 1 square minus 2, which gives us 3 minus 2, giving us 1 radian per second square. This is the last question here. Thank you, everyone.
On a simpler side as compared to January shift.
All right, it's simple.
Yeah,
Nice.
relatively simple, but certain topics.
Hi everyone, welcome back. Now that you know that you have seen the JEE Main live reaction of the students of today's shift, now it's high time to see the teacher's reaction to the questions. So we have gotten and received a lot of memory-based questions from the students, and now it's high time to know the teacher's opinion and reaction to today's paper. So we'll start with Neha ma'am.
Yeah, as far as chemistry paper is concerned, I will grade this paper on a simpler side as compared to January shift.
All right, it's simple.
Yeah,
Nice.
relatively simple, but certain topics continue to dominate.
Yes.
As they were there, like atomic structure again is there. Till now we have got almost 20 questions out of 25, in which we have seen that atomic structure is again asked, molecular bonding is there, but some new changes like vitamins and biomolecules were quite neglected in session 1. They have found their place this time. Kinetics continue to rule, thermodynamics is covered. So again, the paper overall content is similar to session 1 January shift, but on a slightly simpler side.
Simpler side,
Yes,
all right.
just few calculations here and there for physical.
Right. And if I want to ask you that, how do you divide between the three subjects, that is organic, physical and inorganic?
Yes, all
Right?
three seems to have uniform dominance in the overall paper till now. One or two question here or there maybe, like physical seems to be slightly one or two question more than
Heavier,
others. Yes,
heavier dominance,
Yes,
all right.
Otherwise, this paper I'll find it to be simpler. Organic is like in session 1 was multi-conceptual. This time very direct questions are there.
Direct questions.
Direct
all right.
questions are back to
Back on the track. We appreciated a lot about the NTA,
Session
but
one.
now
Yeah, maybe coming shifts.
We can see- we
Yeah,
can see a
coming
change,
shifts will
yeah.
show back the same color.
all right. Thank you so much, ma'am.
Yes.
Sir, over to you.
Thank you. So looking at the questions that we have seen, physics is more or less, as I said earlier in the earlier session also, that the paper is spread over the entire subject. It is
Alright.
not that one of the particular topic is much more.
All right.
But more or less it is on the expected pattern.
Okay.
Like we have a questions on dimensions, and in thermodynamics we have a question on adiabatic process, and it is very common that they ask like lengthy calculation based questions on thermodynamics.
Right.
So NTA has lived up to the expectation and given a similar kind of paper.
Nice, nice.
So there are few questions which are very easy. At the same time, one or two questions are there which involve a lot of calculations.
All right.
So overall it is balanced with the subject spread over current, electricity, magnetic effects, fluid, everything has been
Everything
covered.
is there.
So I think all parts of the syllabus have been touched by NTA.
Perfect.
But physics is has not given any surprise this
No
time.
surprises, all right.
surprises.
It's as per the expectation, as per the pattern.
Yeah, so I'm sure physics is going to be high scoring.
Sir, if I give you on a scale of 10, how would you rate this question paper?
So as far as if you talk about grading, so it is JEE Main. So with
Right.
respect to JEE Main, I am saying that paper is 9 out of 10.
9 out of 10. Perfect.
Very well balanced across all subjects. Nothing very tricky.
Nothing tricky. All
Yeah.
right.
So a student who has done well for his board examination and prepared well for 2 years, he must do well in this exam.
Perfect. Perfect. All right. Ma'am, will come to you for the number. Sir, but I want to know your reaction for mathematics. How is the paper?
The questions which I have memory based, if I look at those questions, paper is easier.
Easy. All right. Mathematics is
Maths-
easy.
So surprise.
So if maths is easy, that means physics will get 100%.
Questions are regular questions, direct questions. In these questions, one question having calculation, but only one question till now I have seen. Language, yes, they have changed, like little bit tricky.
Little bit tricky. Yeah.
Otherwise, all the things are good and direct questions.
So what are the questions lengthy?
Not that much.
Not that much.
Except one question which I have
yeah,
right now.
Yeah. So like you did not live up to the expectation of mathematics standard of lengthiness. Is it?
It is easier than
It is easier.
previous, whatever the papers
All
are
right.
there.
This is only the first shift. Correct.
We have 9 more to come.
Correct. Absolutely.
In last session also, first paper was easier. So we start to conclude.
Students should not be becoming careless.
Sure.
Correct. Sir, on a scale of 10, how would you rate this question paper?
At this moment, I don't have all the questions, and what I am able to see, there are, they have covered only few topics. So whenever paper will come, that time only I can.
All right. You will be able to rate it.
Yeah.
All right. Okay. Ma'am, over to you. How would you rate this entire question paper?
So till now we have got around 20 questions, and like rating the paper, if I consider, like I'm not rating on the toughness scale. Toughness is just 6 or 7, I'll say.
Okay.
But again, as sir said, that it is the mains paper, we should consider any 12th going usual student without any support, then the paper is good. Conceptual, I'll grade it at somewhere like 7.58, not more than that.
7.5 to 8.
Yeah,
All right.
yeah.
All right.
Till now. But
Okay.
maybe 5 questions when come,
Yeah.
I don't know.
That's okay. Now, I would just want to know that how do you see the pattern of the question paper? Like, is it different from the session 1 that we saw in the January session, or how is it?
Yes, as this is just the first paper out of 10th, I'll grade this one relatively on the simpler side as
Simpler
compared to
side.
January session.
Ma'am, but is it because we have just seen only one shift's question paper?
Yes,
So is
so
it
we-
just because of the first shift?
It is just a random distribution of paper. I would not say it is first shift or any shift. It
Okay.
is mere coincidence that in both January and April, first shift
Has been a bit easier.
has been a bit easier.
Yeah.
But that is no generalization. It could be anything in coming 9 sessions.
All right. Sir, over to you.
So, well, the paper certainly has 1 or 2 surprise questions. So, it is like you are going through the questions and all questions are coming easy, and all of a sudden then there is a question
Okay.
which has a lot of tricks or maybe lengthy calculations.
Correct.
And you really have to go deep to understand how to solve this. So, like multi-step. So, and that is very common thermodynamics. Usually it happens in
Correct,
thermodynamics. So there is a question in which you need to think over, okay, what is the information given? So indirect information has been given instead of a direct information. So that is going to take time. And I think this happened in January shift also.
January shift as
There
well.
were few questions which were not directly formula based. So you need to like sit over, think, and then manipulate the things to get the answer.
Correct.
But 1 or 2 questions like that.
All right.
Otherwise, it is a general.
It's a general,
normal
like
paper.
it follows the general trend, but a couple of questions are a bit on the higher level in
Yes.
which you have to apply the multi-concepts or multi-level of thinking.
Multi-level of thinking or multiple steps of calculation.
Multiple steps of calculation. Perfect. Sir, how do you see the question paper in terms of pattern?
Pattern is almost same. Just questions are simple as compared to last session. So today maths. Yes, in there are some questions where students have to understand. Like one of the question I can see, they are asking sum of roots, but basically it is sum, and sum is giving. Sorry, it is going to be technical.
Yeah, not an issue.
Sum
Please
is
go ahead.
giving sum of product of first n terms.
Okay.
So it is a blending of sequence and series and quadratic equations.
So basically, there's a blend in two different concepts.
Yeah.
That I can understand.
That is
Yeah.
means that is the little tough thing which is present in the exam. Rest.
So what do you think, like if you see the question paper at the first glance, because it is again a memory based question, a lot of questions we might not have, right? So if you see the question paper at this glance, how do you think that a student might have felt during the examination hall?
He will be happy.
He will be happy seeing the mathematics. Sir, what about physics?
Well, physics, as I said earlier, no surprises, but it's not like that the student will feel very much comfortable because the questions definitely involve calculations.
Calculations,
So
alright.
it is not that just write the formula and get
Correct,
the answer. So
correct.
you have to solve efficiently, and the options are quite close to each other. So you have to like do careful mathematical calculations.
Perfect, perfect.
So that is
options
where-
are like, options can confuse if the calculation is not
Right.
done properly.
So if a student has not done proper practice of solving questions in 3 hours, then they are going to be like feeling short of time in this paper. A student who has rigorously done practice for 2 years, he should not face a problem.
All right. Perfect. Ma'am?
Well, my opinion is if January shift they would have seen and prepared their mind for that type of paper, they would have definitely felt much comfortable and happy after seeing this paper. But in integers, 1 or 2 questions require the same care. I would
Correct,
say
correct.
just, but till now, I would say only 2-3 questions are like that. And in this particular paper, again, I'm missing that multi-conceptual questions that
Okay.
appeared in last shift.
So the
last
surprises
session.
are not there in chemistry.
Till
sir.
now, I'm
That's why it
not
got
so
7.5.
happy.
Itself is a surprise.
Yeah, that itself is a surprise. Some of the questions are like very easy.
Yeah.
So 2-3 questions in entire 25 of that level is not that time consuming.
Right.
So again, as Sarah said, maths has gone a little easier, chemistry has gone. So score will go high.
Yes.
Yes.
This is memory based. No? I don't have too many questions to.
Yeah. But still, as compared to session 1, it seems to have a, it seems to be that we might have a higher score this time.
Let's keep our finger crossed.
Yes, yes.
Perfect, perfect. We will keep our fingers crossed. We'll see how the students score.
Yes.
All right. Now, if I talk about the time management perspective, because mathematics is not that lengthy, seeing the memory-based questions, of course. So, how do you think the student must be happy in the examination hall? And then, will the student be able to answer all the questions? How the student mindset would have been?
Well, that is very personal judgment on student to student that how they will react to. Because what we are talking is after analysis of so many reviews of students.
Correct, correct.
When the student is there inside examination hall and seeing this paper which he or she might have prepared for so long, they won't accept it to be so simple on a first go. They'll think, something I am missing. It must be
Okay,
very
okay,
important.
that
It must
way.
be very important. As far as I think, because they don't accept that feeling that it is so easy.
It is easy.
It will, wise students will still be careful, will take their conclusions and judgment like on spot, but with care. So I don't think it should impact much on good students' performances.
Right, right. So my question to you is one piece of advice that you would like to give seeing this question paper to the future aspirants.
So the most important aspect as far as physics is concerned would be to read the questions carefully and to be careful about the data.
Correct.
Like as I can see, there is a question in thermodynamics. So the temperature has been mentioned in 100 degrees Celsius, 140 degrees Celsius.
Right.
And we need to convert it in Kelvin first before solving. And
Nice.
those students will forget this thing.
Right.
So the pressure is given in bar instead of standard SI units.
Right.
The temperature is given in degrees Celsius. It should have
Correct.
been in Kelvin.
Kelvin.
So these factors are to be taken care of. Nothing special, but reading mistakes should
Reading
not be
mistakes
there.
should be avoided.
So-
Okay.
yeah.
Ma'am, over to you.
Well, I think that particular factor applies to all 3 subjects. What Sir has said should be taken in all 3 subjects because that is there in our paper also. Like they have clearly asked which does not decolorize cold alkaline, and sometimes they have given an entire reaction or formula, and student may consider that they are asking about reactant. In the corner they written about the products. This statement is true. So
Okay.
that thing is like common for mains, advanced, PCM, maybe even PCB also, we don't know, but that is a fixed factor everyone has to take care of. Like signs are there, they have to be carefully judged. Options
Right.
are closed as usual.
Yes.
So that is a fixed thing.
That
They
the-
need to be careful with reading.
As well as choosing the options.
definitely very, very close at times.
Right. Sir, I would like to know your piece of advice to the future aspirants.
Don't consider this paper that
Benchmark.
benchmark. Their preparation, whatever the preparation they are doing, they should continue. And whatever practice they are doing, they should do
Continue
that.
doing that. Yes.
They should not judge anything because of this paper.
Correct. Right. So basically, students, don't be judgmental. Read the question paper nicely and choose the options very carefully. This is the crux from all the 3 star faculties of ours today. Well, thank you so much, sir, for your valuable input. Now it's high time to see the students' reaction because the examination is over by now and our team is there to capture their live reactions. So let's go and see how the students wrote their JEE Main Session 2.
Hello everyone, I am Suchetna
I am Avijit.
and welcome to
Narayana Educational Institutions.
So, the JEE Mains Exam 2026 Session 2 just got over. And students are just walking out after writing one of India's toughest engineering entrance exams.
And we are here to capture the live reactions of the students. So, let's go. What's your name?
Srishank.
Srishank. You have just appeared for JEE Main Session 2. How did your exam go?
Pretty moderate.
Pretty?
Moderate.
That's good. And what about Session 1? Have you appeared for Session 1?
Yeah.
What did you feel? Which one was more difficult, Session 1 or Session 2?
Session 2.
Session 2 was
Yeah.
more difficult.
Hello, what is your name?
Myself, K. Shriman. I am an intermediate second year student from Adipatla Narayana College.
So, you just appeared for the JEE Mains Session 2 exam. How was your exam?
I had written well compared to the first session, but some of the questions were asked differently from the first session. Most of them has thought they would be replica questions from the first session, but some of the questions are asked different compared to the first session.
Which subject did you have more difficulties?
I would say that physics and maths, but entirety, chemistry and physics was moderate. Maths too was also moderate.
Maths was very difficult. Which topic of maths? Was it calculus? Was it algebra?
Calculus regarding indefinite and definite were asked in different compared to the session 1.
Hello, what's your name?
My name is Sudeep Chandan.
You have just appeared for JEE Main Session 2. How did your exam go?
It's not well.
It's not well? Did you feel it is difficult?
Not difficult, but I didn't write well.
You didn't write well. Did you also appear for Session 1?
Yeah.
What was, in comparison, Session 2 was more difficult?
No, it's easy.
It's easier.
Paper 1.
Which subject do you feel is more easier or more difficult for you?
All were easy.
All were easy. So, which part did you write the best in the exam?
Maths.
Maths. Maths you felt it is easier?
Yeah.
What about physics and chemistry?
Those are also easy, but I'm good at maths. That's why I felt maths very good.
Okay. Hello, what's your name?
My name is Bhuvan Karthik.
So you have just appeared for JEE Main Session 2.
Yeah.
How did your exam go?
It went well.
It went well?
Compared to the first session, it was good.
So you have also appeared for Session 1.
Yeah.
So compared to that, you felt it is good.
Yeah.
That's very good. So which part do you feel that it was more easier? Which subject?
Maths was way more easier compared to remaining two.
Maths was way more easier. What did you feel the exams, what did you feel the question that has come, they are following a trend or it was little exceptional?
No, some questions are like depending on the weightage of the lessons. Remaining are always some questions are repeated every year.
Are repeated.
Yes,
okay.
So if we study the according to the more weightage questions, we'll obviously score more than we expected.
Very good.
Hello, what is your name?
Avi Guruveli.
So you just appeared for the JEE Main Session 2 exam. How was your exam?
It was comparatively easier than the first one at least.
So you appeared for Session 1, right?
Yeah.
Okay, so where did you find it was easier? Which subject?
Physics and chemistry were comparatively easier. I mean, it's all on the basis of how you prepare. No? First session was kind of a bit difficult.
So you prepared better this time, you're saying?
Yeah.
All right, so which section did you find most difficult this time?
Oh, maths, because you need a lot of preparation for maths, and then you just can't get that from session 1 to session 2. Like the jump is not there.
Right. So which topic of maths did you find most difficult questions from?
Conic sections.
Right. And how many questions did you attempt?
I attempted approx 35.
35. So, do you think the paper was really lengthy, or you could manage time across all sections?
Maths was lengthy, I mean for me. But then physics and chemistry were doable, they were good.
Hello, what's your name?
My name is Sharan Agastya.
You have appeared for JEE Main Session 2. How did your exam go?
The exam was pretty good. I felt maths was a bit hard, but physics and chemistry was really good. And I prepared really good, and I feel like this will definitely boost my energy, and I'll get good percentile.
Very good. Did you also appear for Session 1?
Yeah, I appeared for Session 1 on 28th, the second shift. Comparing, this was a little tougher, especially the maths. Physics and chemistry were good.
So what did you feel like in maths? Which portion of the maths or which topic of maths was more difficult?
Conic sections was little difficult, and overall in the paper the numericals were a little tough, and they need to be more calculated.
The numericals were tough for physics and chemistry also?
Yeah, they were at least doable, but maths were a little tough.
Hello, what's your name?
My name is Ansh.
Ansh. You have just appeared for the JEE Main Session 2.
Yes.
How did your exam go?
It was okay, fine, moderate, I would say.
It is moderate. Did you also appear exam for Session 1?
Yes, I did.
You also appeared for Session 1?
Yes, I attempted.
What did you feel was more difficult, Session 1 or Session 2?
I felt Session 1 was much difficult because I got the 23rd Jan second shift, which was much difficult than this shift.
Okay. So which topic or which subject do you feel was more easier in Session 2?
So vector 3D and from math and from physics, I would say rotational motion, because they asked us about torque and all. That was much easier than last time.
Wonderful.
Hello, what is your name?
My name is Charan, madam.
So, you just appeared for the JEE Mains exam, Session 2. How was your exam?
Yes, madam, it is a very experience to me. Why? Because I am a competitive for JEE Mains 2. This is a moderate exam, madam.
Moderate exam. Did you appear for Session 1?
Yes, madam, Session 1. I attended Session 1.
Okay, so how was it compared to Session 1? Was it better or more difficult?
Yes, madam, it is better. It is some moderate exam for Session 1. Session 1 is hard, madam. It is some simple questions and moderate questions are come, madam.
Okay, so which subject did you find most easy and most difficult?
Maths, madam. Maths is a most moderate, madam. Not easy, not difficult. It is a moderate, madam. Hardest means physics, madam.
Hardest was physics. What was so hard about physics? Was the entire paper or some topics?
Some topics, madam.
Which topic?
That rotation motions, that's like topics, madam.
Rotational mechanics, right? That was difficult. Right. And what about chemistry?
Chemistry is totally some 10 questions, 10, 12 questions are theory questions, madam. That is too difficult to read the questions for time and management.
Okay. Organic or inorganic? Which one did you find more difficulty?
Inorganic. Organic is less questions are coming, madam.
All right. How many questions did you attempt in total?
43, madam. Total 43.
Amazing. And hello, what is your name?
My name is Megamsh.
Megamsh. So you just appeared for the JEE Mains exam. How was the exam?
It's wonderful. Medium.
Medium. So did you appear for Session 1?
Yes, ma'am.
Which was better, Session 1 or Session 2?
Session 1 only.
Session 1. Why do you feel so? Which parts were difficult this time?
Physics and chemistry.
Physics and chemistry was more difficult this time, you're saying?
Yes, ma'am.
All right. So which one did you find most easy? Maths was easy?
Some questions are easy. 3 to 4 questions.
Okay. Which section did you struggle most with?
Section A.
For?
MCQs.
For which subject?
Maths.
Maths MCQs you struggled with. How many questions did you attempt in total?
Total 36 to 38.
What's your name?
Hi, I'm Utkarsh.
You have just appeared for JEE Main Session 2. How did your exam go?
It was decent. I would say it was better than the Session 1 for me.
That's so wonderful. What did you feel like? How was Session 2 better than Session 1? Like, which topics were more easier, and how did you fare in Session 2 questions?
I would say I was more prepared for Session 2. That's why I felt Session 2 was easier for me. Paper difficulty wise, I would say Session 2 was a bit difficult. Difficulty was more, but my personal experience was better in Session 2.
Okay, that's great. That's wonderful. Which subject do you feel that was more easier for you for Session 2?
I felt physics the easiest.
Physics is the easiest. Yeah, we are also getting to know this from the other students. And what about maths and chemistry?
They were at decent level only. I won't say they were very tough. Chemistry was more or less, the questions from inorganic were very easy. Physical consisted two questions from mole concept, so it is an easy topic. decent topic. From maths, more like pattern-based questions were there. I would say 5 to 6 pattern-based questions. I found 5 to 6 pattern-based.
Wonderful. How many questions did you attempted in total?
I attempted 50 questions.
50 questions. Yeah. And how much you're confident about session 2?
Say around 40 questions. I should be able to get 40 questions correct.
Are you also aspiring for JEE Advanced?
Yes, I am.
Any preparation plan for that?
Preparation plans, I don't think so. I will continue the pace I'm continuing, and let's see what.
Any tricks and tips for other JEE aspirants?
Other JEE aspirants. Okay, for maths, you can go just check the pattern-based questions once more, questions from 3D geometry and from AP there were questions. So for maths, check out the pattern-based questions. Inorganic, I felt easy, so do that. And
wonderful, wonderful. Thank you for your time, and I wish you best of luck for your future exams. Thank you. So that was all for the reactions we have got from JEE Main Session 2. We got a mixed bag of reactions, to be honest. Some students felt Session 1 paper was easier than Session 2. Some students felt the otherwise. But one thing was common. Students who were prepared well, fared well.
You can also let us know how your exam went down in the comments. Also, people who are appearing for the upcoming exams, upcoming shifts, all the very best to you. Keep preparing, keep studying, because at Narayana, your dreams are our dreams.